Welcome to Tech with Koushik. This is set 3 of our AI-200 Microsoft Certified Azure AI Cloud Developer Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 3. Focus on the key wording in question number 82. We are now working with metric alerting. This scenario tests whether you recognize the controlling constraint. An AI API publishes a numeric response latency metric. Operations must trigger an alert whenever the average latency is greater than 2,000 milliseconds during a 5-minute evaluation window. Which Azure Monitor alert design best matches the requirement? The exam distinction is hidden in these choices. Option A. A service health alert for Azure platform incidents only. Option B. An activity log alert for resource creation events. Option C. A metric alert using the latency metric, average aggregation, a 5-minute window, and a static threshold. Option D. A free text log search that looks only for the word slow. The required response is option C. A metric alert using the latency metric, average aggregation, a 5-minute window, and a static threshold. The key clue points here because a metric alert directly evaluates a numeric signal using the required aggregation, comparison operator, threshold, and evaluation window, which matches the latency condition precisely. Here is how to rule out the alternatives. A. Service health alerts report platform service incidents, not an application latency threshold. B. Activity log alerts monitor resource management events. D. Free text log matching is less direct than evaluating the numeric metric requested. Watch for this clue in similar questions. Use metric alerts for numeric threshold conditions. Attach an action group when notifications or automated actions are required. Question number 83 is a good test of exam judgment. The key exam clue is contained in this scenario. A generative AI application must inspect generated responses for harmful categories before returning the content to users. Which capability directly addresses this requirement? Focus on which option satisfies the complete requirement. Now examine choice A. Increase the model's maximum token count. Now examine choice B. Disable application logging. Now examine choice C. Add a content safety filtering or moderation step to the response pipeline. Now examine choice D. Configure a CPU utilization alert. The option that satisfies the complete requirement is option C. Add a content safety filtering or moderation step to the response pipeline. Content safety filtering evaluates model output for harmful categories and can annotate or block content according to configured safety thresholds before the response reaches the user. The incorrect choices are plausible, but unsuitable because A. Token limits control response size, not harmful content detection. B. Disabling logs does not moderate generated content. D. CPU alerts monitor infrastructure behavior, not content safety. Use this elimination rule in the exam. Content moderation and infrastructure monitoring solve different problems. Harmful output control requires a safety filter in the content path. For question number 84, separate the requirement from the distractors. Pay attention to qualifiers such as least, most, and minimum. An Azure-hosted OpenAI resource must be accessible from a workload connected to a specific virtual network. Direct access through the public endpoint must be disabled. Which network configuration satisfies the requirement? Watch for distractors that are valid services but wrong for this scenario. Consider option A. Create a private endpoint for the resource and disable public network access. Consider option B. Keep the public endpoint enabled and rely only on application secrets. Consider option C. Configure a key vault access policy. Consider option D. Configure a content filter. After elimination, select option A. Create a private endpoint for the resource and disable public network access. The decisive reason is a private endpoint gives the resource private connectivity through the virtual network. Disabling public network access ensures the public endpoint cannot be used for direct client access. B. Secrets authenticate callers but do not eliminate the public network path. C. Key vault authorization does not configure model resource networking. D. Content filters govern content, not network reachability. A useful exam pattern is this. Use private link for private service access and disable public network access when the public endpoint must not remain usable. Question number 85. Find the decisive clue before choosing. This question moves us into KQL log analysis. Look for the wording that eliminates the distractors. A production AI service emits Azure Resource Diagnostic logs. Engineers need to investigate those logs interactively by using KQL. Where should the diagnostic settings send the logs? Eliminate every option that violates even one requirement. Next, option A. Only to an event hub that has no downstream consumer. Next, option B. To a log analytics workspace. Next, option C. Nowhere, because diagnostic logs cannot be queried. Next, option D. Only to an archival storage account. The best answer is option B. To a log analytics workspace. Here is the reasoning that confirms the answer. Log Analytics stores Azure Monitor log data in tables that can be queried interactively by using KQL, which directly supports troubleshooting and analysis. Check why each remaining option is not the best fit. A. Sending only to an event hub without a consumer does not provide an interactive KQL log store. C. Diagnostic logs are useful and can be queried after ingestion. D. Storage is useful for archival but does not provide the same native KQL investigation experience. Route diagnostic logs to log analytics when engineers must query and correlate them with KQL. Work through question number 86. Step by step. Start by separating the facts from the requirement. A developer has an Azure RBAC role assignment scoped only to one existing AI service resource. The developer must also create additional resources of that type inside the containing resource group. Why might the current role assignment be insufficient? Now compare the choices one requirement at a time. Choice A, resource scope permissions automatically apply upward to the containing resource group. Choice B, Azure AI resources cannot use Azure RBAC. Choice C, a role assigned only at the existing resource does not grant resource group level create permissions. The required role must be assigned at the resource group or a higher scope. Choice D. Replacing the current role with reader at the same resource scope grants create permission. The correct choice is option C. A role assigned only at the existing resource does not grant resource group level create permissions. The required role must be assigned at the resource group or a higher scope. This option satisfies the complete requirement because Azure RBAC assignments apply at their assigned scope and inherit downward. A permission granted only on one existing resource does not inherit upward to the resource group, where creation of new resources is authorized. Now eliminate the distractors. A. RBAC inheritance flows from broader scopes to child scopes, not upward. B. Azure AI resources can use Azure RBAC. D. Reader does not grant resource creation permissions. Remember this decision rule. Always evaluate both the role and its scope. A sufficient action in a role is useless when the assignment scope does not include the target operation. Approach question number 87 by checking every constraint. This medium question rewards structured elimination. Identify the decisive constraint before considering the options. A Python application retrieves a key vault secret by secret name and does not specify a version. The secret is rotated, creating a newer version under the same name. What occurs the next time the application retrieves that secret from key vault without supplying a version? Compare the options by fit, not by familiarity. Next, option A. Key vault returns the latest applicable version of the secret. Next, option B. Key vault requires the entire vault to be recreated. Next, option C. Retrieval fails until the previous version is deleted. Next, option D. Key vault always returns the original version unless the application is redeployed. After elimination, select option A. Key vault returns the latest applicable version of the secret. The requirement to solution match is when a secret is requested by name without specifying a version. The retrieval targets the current version rather than pinning the application to an older version identifier. The remaining options fail one or more requirements because B. Secret rotation does not require recreating the vault. C. Older versions do not have to be deleted for a newer version to be retrieved. D. A versionless key vault retrieval is not permanently bound to the version that existed at deployment time. Exam strategy. Pin a secret version only when immutability is required. Versionless retrieval supports consuming newer secret versions after rotation. Question number 88. Tests careful elimination. Look for the wording that eliminates the distractors. A model-backed application receives HTTP 429 responses from an Azure OpenAI endpoint, and the response includes retry after guidance. How should the client handle the throttled requests? Eliminate every option that violates even one requirement. Consider option A. Retry immediately and continuously with no delay. Consider option B. Wait for at least the indicated retry interval and use controlled backoff for subsequent retries. Consider option C. Stop using the endpoint permanently after the first 429 response. Consider option D. Change an unrelated database consistency setting. The required response is option B. Wait for at least the indicated retry interval and use controlled backoff for subsequent retries. The key clue points here because HTTP 429 indicates throttling. Respecting service-provided retry timing and applying bounded backoff prevents immediate retry storms while allowing transient throttling to recover. Here is how to rule out the alternatives. A. Tight loop retries increase pressure on the throttled service. C. A 429 is not necessarily a permanent failure. D. Database consistency does not control model endpoint throttling. Watch for this clue in similar questions. For retriable throttling, honor retry after guidance first and use bounded backoff rather than immediate repeated calls. Question number 89 contains an important exam distinction. We are moving to Azure authentication. Focus on the requirement that drives the design choice. An Azure-hosted application uses managed identity to call several Azure services. Custom code explicitly requests a new access token before every service operation, even when the current token has not expired. What improvement should the developer make? The exam distinction is hidden in these choices. Option A. Continue requesting a new token for every operation because token reuse is unsupported. Option B. Replace managed identity with a shared administrator password. Option C. Cache and reuse valid access tokens, or rely on supported Azure Identity credential implementations that manage token reuse. Option D. Disable authentication for the downstream services. The option that satisfies the complete requirement is option C. Cache and reuse valid access tokens, or rely on supported Azure Identity credential implementations that manage token reuse. Managed identity access tokens remain valid for a period of time. Reusing a valid token avoids unnecessary token endpoint calls, reduces latency, and lowers the risk of identity endpoint throttling. The incorrect choices are plausible, but unsuitable because A. Requesting a fresh token for every operation adds avoidable overhead. B. A shared administrator password weakens security and is unnecessary. D. Disabling authentication is not an acceptable optimization. Use this elimination rule in the exam. Reuse valid access tokens and let supported credential libraries manage token acquisition whenever possible. Now tackle question number 90. Identify the requirement in this scenario. A platform team is selecting system-assigned and user-assigned managed identities for Azure workloads. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. Test this claim. Deleting an Azure resource also deletes the system-assigned managed identity whose lifecycle is tied to that resource. Statement 2. Test this claim. A Key Vault simultaneously uses both its legacy access policy model and Azure RBAC data plane model for authorization without choosing between the models. Statement 3. Test this claim. A user-assigned managed identity can be created before a workload resource and then attached when that workload resource is deployed. Statement 1 is yes. A system-assigned identity is created for one resource and is removed when that resource is deleted. Statement 2 is no. A vault uses the selected data plane permission model. Switching to RBAC makes access policy permissions ineffective. Statement 3 is yes. A user-assigned identity has an independent lifecycle and can be provisioned before the workload. A useful exam pattern is this. System-assigned identity lifecycle follows one resource. User-assigned identity lifecycle is independent and supports pre-authorization and reuse. Question number 91 is a good test of exam judgment. Focus on the requirement that drives the design choice. A high-traffic application uses the Azure Monitor OpenTelemetry distro and sends a very large volume of trace telemetry to application insights, increasing ingestion cost. The team wants to reduce trace volume while retaining a representative subset for troubleshooting. Which configuration best fits the requirement? Focus on which option satisfies the complete requirement. Now examine choice A. Disable OpenTelemetry collection completely. Now examine choice B. Configure OpenTelemetry sampling, such as fixed percentage or rate-limited trace sampling. Now examine choice C. Remove every trace and retain no diagnostic context. Now examine choice D. Buffer all telemetry and send it only once each day. The correct choice is option B. Configure OpenTelemetry sampling, such as fixed percentage or rate-limited trace sampling. The decisive reason is Azure Monitor OpenTelemetry supports fixed percentage and rate-limited trace sampling. Sampling reduces exported trace volume and ingestion cost while retaining a representative subset of traces for diagnostics. A. Disabling collection removes trace observability entirely. C. Removing all traces eliminates diagnostic evidence instead of sampling it. D. Delaying telemetry delivery does not reduce the number of traces ingested. With Azure Monitor OpenTelemetry, use supported trace sampling to control telemetry volume. Remember that sampling can reduce the completeness of failure and performance investigations. Question number 92. Find the decisive clue before choosing. The focus now shifts to private endpoint access. Identify the decisive constraint before considering the options. A security review compares two Azure networking controls for accessing a supported Azure service from a virtual network. Which statement correctly distinguishes a private endpoint from a virtual network service endpoint? Compare the options by fit, not by familiarity. Consider option A. The two mechanisms are identical. Consider option B. A private endpoint gives the service a private IP address in the virtual network, while a service endpoint secures access to the service's public endpoint from selected subnets over the Azure backbone. Consider option C. Service endpoints always replace private endpoints for every Azure service. Consider option D. Private endpoints are available only for Azure storage. The best answer is option B. A private endpoint gives the service a private IP address in the virtual network, while a service endpoint secures access to the service's public endpoint from selected subnets over the Azure backbone. Here is the reasoning that confirms the answer. Private link maps the supported service to a private endpoint network interface in the VNet. A service endpoint extends the subnet identity to the Azure service while access still targets the service's public endpoint model. Check why each remaining option is not the best fit. A. The mechanisms use different networking models. C. Service endpoints do not universally replace private link. D. Private endpoints are supported by many Azure services, not only storage. Remember this decision rule. Private endpoints provide private IP connectivity. Service endpoints secure subnet to service access while retaining the service's public endpoint architecture. Let's break down question number 93. First, locate the key operational constraint. An Azure Monitor alert rule detects a high error rate condition. The on-call team must receive both email and SMS notifications when the alert fires. Which Azure Monitor component defines the notification recipients and delivery methods? Review the options and eliminate any clear mismatch. Option A is a resource lock. Option B is a diagnostic setting. Option C is an action group attached to the alert rule. Option D is a key vault authorization policy. The required response is option C, an action group attached to the alert rule. This option satisfies the complete requirement because Azure Monitor action groups define notification receivers and action types. They can send email and SMS and can be reused by alert rules. Now eliminate the distractors. A. Resource locks protect resources from deletion or modification. B. Diagnostic settings route telemetry but do not define alert recipients. D. Key vault authorization does not configure Azure Monitor notifications. Exam strategy. The alert rule defines when to fire. The action group defines who or what is notified or invoked. Approach question number 94 by checking every constraint. Treat this as an easy item and eliminate carefully. Pay attention to qualifiers such as least, most, and minimum. Midway through the billing period, spending for an AI workload is increasing faster than expected. Finance wants an automated warning before monthly spend exceeds an agreed limit. Which Azure capability should be configured? Watch for distractors that are valid services but wrong for this scenario. Next, option A, an application insights availability test. Next, option B, a key vault secret expiration notification. Next, option C, a cost management budget with one or more alert thresholds. Next, option D, historical cost analysis only, with no budget threshold. After elimination, select option C, a cost management budget with one or more alert thresholds. The requirement to solution match is a cost management budget tracks accumulated or forecasted spend against configured thresholds and can generate proactive notifications before the billing period ends. The remaining options fail one or more requirements because A, availability tests monitor endpoint reachability. B, secret expiration notifications do not track workload spending. D, historical analysis reports costs but does not by itself provide the requested proactive budget threshold. Watch for this clue in similar questions. Use budgets for proactive cost thresholds. Use cost analysis for investigating where spending has already occurred. Question number 95 contains an important exam distinction. This scenario tests whether you recognize the controlling constraint. A valid business prompt is blocked by the content filtering configuration on a model deployment. The team suspects a false positive. What is the most appropriate first troubleshooting action? The exam distinction is hidden in these choices. Option A, delete and recreate the model deployment immediately. Option B, inspect the content filter category and severity information for the blocked request, then evaluate whether an allowed configuration adjustment is appropriate. Option C, disable every safety control for all users without investigating the classification. Option D, restart the Azure resource without reviewing the filtering result. The best answer is option B. Inspect the content filter category and severity information for the blocked request, then evaluate whether an allowed configuration adjustment is appropriate. The key clue points here because content filter results identify the harm category and severity that caused filtering. Reviewing that evidence first lets the team distinguish a likely false positive from genuinely unsafe content before changing an allowed threshold or policy. Here is how to rule out the alternatives. A, recreating the deployment does not diagnose the classification. C, disabling all safeguards without investigation is unsafe and may not be permitted. D, restarting the resource does not explain why the content filter blocked the request. Use this elimination rule in the exam. Troubleshoot content filtering from the category and severity evidence first. Change only supported filter settings that fit the application's risk requirements. For question number 96, separate the requirement from the distractors. Next, we enter the topic of security control mapping. Pay attention to qualifiers such as least, most, and minimum. An Azure AI solution uses several identity, secret, authorization, network, and content protection controls. Match each mechanism to its primary purpose. Use each destination exactly once. The left side candidates are left item 1, private endpoint. Left item 2, Azure RBAC. Left item 3, key vault. Left item 4, managed identity. Left item 5, content safety. The right side descriptions are right option A, detect and filter potentially harmful generated content. Right option B, assign permissions to identities at defined Azure scopes. Right option C, provide private network connectivity to a supported Azure service. Right option D, centrally store and control access to secrets, keys, and certificates. Right option E, authenticate an Azure workload without storing application credentials. The defining capabilities produce these matches. Private endpoint matches provide private network connectivity to a supported Azure service. Azure RBAC matches assign permissions to identities at defined Azure scopes. Key Vault matches centrally store and control access to secrets, keys, and certificates. Managed Identity matches authenticate an Azure workload without storing application credentials. Content Safety matches detect and filter potentially harmful generated content. Each mechanism addresses a distinct control plane. Private Endpoint provides private connectivity. RBAC grants scoped authorization. Key Vault protects secrets. Managed Identity supplies credential-free workload identity, and Content Safety evaluates harmful content. A useful exam pattern is this. separate identity, authorization, secret storage, network isolation, and content moderation. Each mitigates a different class of risk. Question number 97. Background. Fabricam operates an internal gateway that calls a model endpoint for a customer support application. Current environment. The gateway currently requires an API credential to call the downstream service. Business requirements. The credential must not be embedded in source code, deployment scripts, or developer documentation. Technical requirements. The gateway has a managed identity and can be authorized to retrieve secrets from Azure Key Vault. Which implementation best satisfies the requirement? Option A. Commit the API credential to the application's source repository. Option B. Store the credential in Key Vault and authorize the gateway's managed identity to retrieve it. Option C. Email the credential to each developer. Option D. Publish the credential in a publicly accessible text snippet. The option that satisfies the complete requirement is option B. Store the credential in Key Vault and authorize the gateway's managed identity to retrieve it. The decisive reason is Key Vault protects secret material outside application code, while managed identity lets the gateway authenticate to Key Vault without storing another credential in the application. The incorrect choices are plausible, but unsuitable because A. Source repositories are not an appropriate location for production secrets. C. Email distributes uncontrolled secret copies. D. Publicly publishing a credential directly exposes it. Keep secret values in Key Vault and use managed identity plus least privileged secret read authorization for Azure-hosted applications. Move to question number 98. Background. Fabricam operates an internal gateway that calls a model endpoint for a customer support application. Current environment. Response latency is already emitted as a numeric Azure Monitor signal. Business requirements. The operations team must be notified when latency degrades before users open support tickets. Technical requirements. The notification must be triggered automatically when latency crosses a defined threshold. Which configuration best satisfies the requirement? Choice A. Disable monitoring to reduce telemetry volume. Choice B. Wait for customer reports before investigating. Choice C. Create a metric alert on response latency and attach an action group. Choice D. Check the Azure status page manually once per day. The correct choice is option C. Create a metric alert on response latency and attach an action group. Here is the reasoning that confirms the answer. The metric alert evaluates the numeric latency signal against the required threshold, and the action group delivers notifications when the condition fires. A. Disabling monitoring prevents proactive detection. B. Waiting for user reports violates the early detection requirement. D. A daily manual status check does not continuously evaluate application latency. Remember this decision rule. Pair a metric alert condition with an action group when a numeric performance signal must trigger proactive notifications. Question number 99. Tests careful elimination. The focus now shifts to private endpoint access. Background. Fabricam operates an internal gateway that calls an Azure-hosted OpenAI resource. Current environment. The gateway is integrated with a virtual network. Business requirements. Traffic between the gateway environment and the model resource must use private connectivity, and direct public network access to the model resource must be disabled. Technical requirements. The Azure OpenAI resource supports private link connectivity. Which network configuration satisfies the requirement? Eliminate every option that violates even one requirement. Consider option A. Keep unrestricted public access enabled. Consider option B. Configure a Key Vault access policy instead of network isolation. Consider option C. Configure a private endpoint for the Azure OpenAI resource and disable public network access. Consider option D. Configure only a content filter. The option that satisfies the complete requirement is option C. Configure a private endpoint for the Azure OpenAI resource and disable public network access. This option satisfies the complete requirement because a private endpoint provides VNet-based private connectivity to the Azure OpenAI resource. Disabling public network access ensures the resource cannot be directly reached through the public endpoint. Check why each remaining option is not the best fit. A. Unrestricted public access violates the network requirement. B. Key Vault permissions do not create private model endpoint connectivity. D. Content filtering is unrelated to network isolation. Exam strategy. Private link controls the network path. Identity and content controls do not replace network isolation. For question number 100, separate the requirement from the distractors. Background. Fabricum operates an internal gateway that calls an Azure-hosted OpenAI deployment. Current environment. During peak demand, the gateway intermittently receives HTTP 429 responses. Business requirements. Transient throttling should not immediately fail all user operations. Technical requirements. The client must avoid creating a retry storm, and the team should determine whether sustained demand exceeds the deployment's available capacity or quota. Which remediation is most appropriate? Compare the options by fit, not by familiarity. Next, option A. Disable content filtering to reduce request count. Next, option B. Replace managed identity with a shared key. Next, option C. Stop all model calls permanently during business hours. Next, option D. Honor retry timing. Use exponential backoff and evaluate whether available throughput or quota must be increased. The required response is option D. Honor retry timing. Use exponential backoff and evaluate whether available throughput or quota must be increased. The requirement to solution match is controlled retries handle transient 429 throttling without amplifying load. If throttling persists under normal demand, the team should also determine whether deployment capacity or quota is insufficient for the workload. Now eliminate the distractors. A. Content filtering is not the primary control for request rate throttling. B. Changing authentication does not add model throughput. C. Permanently stopping peak hour calls is not a resilient throttling strategy. Watch for this clue in similar questions. Treat 429 as a capacity signal. Back off correctly first, then address sustained quota or throughput shortfalls if demand is legitimate. Question number 101. Tests careful elimination. This question moves us into flex consumption billing. Identify the decisive constraint before considering the options. An HTTP-triggered Azure Functions app runs on the flex consumption plan. The HTTP scale group is configured with 2 always-ready instances. During a traffic burst, the app scales to 5 total instances, the 2 configured always-ready instances plus 3 on-demand instances. How is compute usage billed while this condition exists? Watch for distractors that are valid services but wrong for this scenario. Consider option A. Only the 2 configured instances are billed. All scale-out instances are free. Consider option B. The 2 always-ready instances use always-ready billing, while the 3 additional instances use on-demand billing when they execute functions. Consider option C. All 5 instances are billed continuously at the always-ready baseline rate. Consider option D. Flex consumption uses a fixed monthly charge that is independent of instance activity. After elimination, select option B. The 2 always-ready instances use always-ready billing, while the 3 additional instances use on-demand billing when they execute functions. The key clue points here because flex consumption bills configured always-ready instances with the always-ready baseline and execution meters. When demand scales beyond that configured warm capacity, additional instances are on-demand and are billed according to on-demand execution usage. The remaining options fail one or more requirements because A. Additional on-demand execution is billable rather than free. C. Scale out beyond the configured always-ready count is not automatically converted into always-ready baseline capacity. D. Flex consumption is usage-based, not a fixed monthly instance count fee. Use this elimination rule in the exam. Distinguish configured always-ready capacity from demand-driven on-demand scale-out. The 2 use different flex consumption billing modes. Question number 102. Scenario. A serverless document API currently uses the classic Azure Functions consumption plan. The team needs virtual network integration and wants optional warm capacity to reduce cold start latency, while retaining consumption-based serverless scaling rather than moving directly to premium. Which hosting plan best satisfies these requirements? Compare the options. Option A. Azure Functions Flex Consumption. Option B. App Service Basic. Option C. Azure Container Instances. Option D. Dedicated App Service Plan with Autoscale disabled. The best answer is option A. Azure Functions Flex Consumption. Flex consumption retains serverless scale-to-zero billing while adding virtual network integration, selectable instance sizes, faster scale-out, and optional always-ready instances for reducing cold starts. Here is how to rule out the alternatives. B. App Service Basic is not the functions serverless plan designed for this combination. C. Container Instances is container compute, not the requested functions hosting plan. D. A dedicated plan does not preserve the requested consumption-based serverless model. A useful exam pattern is this. Flex Consumption is the recommended serverless functions plan when you need VNet integration or optional always-ready capacity without moving to premium. Question number 103. Find the decisive clue before choosing. We are moving to Kata scaling. Look for the wording that eliminates the distractors. A background worker runs an Azure Container Apps and consumes AI enrichment jobs from an Azure Service Bus queue. Replica count must increase when the number of pending queue messages grows, even though the worker receives no HTTP traffic. Which container apps capability enables this scaling behavior? Compare the options by fit, not by familiarity. Next, option A. A Kata-based custom scaling rule for Azure Service Bus. Next, option B. The built-in HTTP concurrency rule only. Next, option C. A fixed hourly cron script that manually changes replica count. Next, option D. Container apps cannot scale from non-HTTP signals. The correct choice is option A. A Kata-based custom scaling rule for Azure Service Bus. The decisive reason is Azure Container Apps integrates Kata for event-driven custom scaling. An Azure Service Bus scaler can monitor queue backlog and adjust replica count independently of HTTP traffic. The incorrect choices are plausible, but unsuitable because B. HTTP concurrency is only one possible scaling signal. C. Manual hourly polling does not provide workload-driven auto-scaling. D. Container Apps supports multiple non-HTTP Kata scalers. Use a Container Apps custom scale rule when replica count must react to an external event source, such as Service Bus. Next is question number 104. Review the scenario. 2 containerized services publish and consume business events. Developers want application code to call a broker-neutral pub sub API so that the backing message broker can later be replaced by changing infrastructure configuration rather than rewriting the service code. Which building block provides this abstraction? The choices are option A. Dapper pub sub with a configurable pub sub component. Option B. Direct Service Bus SDK calls embedded in each service. Option C. A shared static IP address. Option D. Azure Traffic Manager. After elimination, select option A. Dapper pub sub with a configurable pub sub component. Here is the reasoning that confirms the answer. Dapper exposes a broker-neutral pub sub API while the backing broker is selected through a component definition. Applications can publish and subscribe through Dapper without embedding broker-specific SDK logic. B. Direct SDK calls couple application code to the selected broker. C. A static IP does not abstract messaging semantics. D. Traffic Manager handles DNS-based traffic distribution rather than application pub sub. Remember this decision rule. Dapper separates application-facing building block AP is from infrastructure-specific component configuration. Let's analyze question number 105. Review the scenario and identify what must be achieved. Several application images are built by Azure Container Registry tasks and reference the same runtime base image. When that base image is updated with operating system patches, the dependent application image should rebuild automatically. Which AC or tasks capability is designed for this requirement? Check each option against the exact requirement. Option A is a base image update trigger that tracks the dependency and starts a new task run. Option B is a source code commit trigger only. Option C is a nightly manual rebuild with no dependency tracking. Option D is AC or tasks cannot react to base image changes. The option that satisfies the complete requirement is option A. A base image update trigger that tracks the dependency and starts a new task run. This option satisfies the complete requirement because AC or tasks can discover an application's runtime base image dependency during a build and automatically trigger a rebuild when the tracked base image is updated. Check why each remaining option is not the best fit. B. Commit triggers react to source changes rather than only to base image updates. C. A manual schedule lacks dependency-aware triggering. D. ACR tasks supports base image update triggers. Exam strategy. ACR tasks can react to source commits, schedules, and tracked base image updates. Choose the trigger that matches what changed. Approach question number 106 by checking every constraint. Next, we enter the topic of flex instance sizing. Pay attention to qualifiers such as least, most, and minimum. A team changes an Azure Functions Flex Consumption app from a smaller memory size to a larger supported instance size. They expect that running fewer instances will automatically guarantee a lower bill. What cost consideration makes that assumption unsafe? Eliminate every option that violates even one requirement. Next, option A. Instance memory size has no effect on flex consumption billing. Next, option B. A larger memory allocation increases the gigabyte-second amount during billable execution or always-ready baseline time. So total cost depends on both memory size and workload behavior. Next, option C. Memory size changes only cold start latency and never affects billing. Next, option D. Flex consumption does not allow instance size selection. The required response is option B. A larger memory allocation increases the gigabyte-second amount during billable execution or always-ready baseline time. So total cost depends on both memory size and workload behavior. The requirement to solution match is flex consumption uses the configured instance memory size in its gigabyte-second billing meters. On-demand instances accrue memory usage while functions execute, while always-ready instances also accrue baseline memory usage. A larger instance therefore increases billable gigabyte-second amounts for the same build time, so using fewer instances does not by itself guarantee a lower total cost. Now eliminate the distractors. A. Instance memory size is part of flex consumption gigabyte-second billing. C. Memory size affects billable compute usage as well as runtime characteristics. D. Flex consumption supports selectable instance memory sizes. Watch for this clue in similar questions. For flex consumption, consider both instance memory size and build execution or always-ready time. Fewer instances do not automatically mean lower cost. Start by identifying the requirement in question number 107. Read the scenario with the target outcome in mind. A stateful HTTP application runs in Azure Container Apps in single revision mode. It keeps temporary conversation state in replica memory, so requests from the same client should continue reaching the same replica while that replica remains available. Which ingress feature should be enabled? Use the scenario constraints to assess these choices. Choice A. Session affinity using sticky sessions. Choice B. Weighted traffic splitting between multiple revisions. Choice C. Disable all scaling rules. Choice D. Move the application to the classic functions consumption plan. The best answer is option A. Session affinity using sticky sessions. The key clue points here because Container App Session Affinity uses an HTTP cookie to route a client back to the same replica while it remains available. The capability is supported with HTTP ingress in single revision mode. The remaining options fail one or more requirements because B. Weighted revision traffic controls how requests are distributed between revisions, not persistent affinity to one replica. C. Disabling scaling does not provide a client affinity mechanism. D. Changing hosting plans does not configure Container Apps replica stickiness. Use this elimination rule in the exam. Traffic weights, choose revisions. Sticky sessions, choose a replica for a client. In Container Apps, Session Affinity requires HTTP ingress and single revision mode. Question number 108. Find the decisive clue before choosing. We are moving to GPU cold start. Look for the wording that eliminates the distractors. A containerized inference service loads a large GPU model during replica initialization. The initialization process is slow, and the service is allowed to scale to 0 during idle periods. What is the main user-facing risk of this scaling configuration? Watch for distractors that are valid services, but wrong for this scenario. Consider option A. The first request after an idle period can experience substantial latency, while a new GPU replica initializes. Consider option B. GPU containers are unable to scale under any Azure Compute service. Consider option C. Scale to 0 eliminates all startup work for the next request. Consider option D. GPU applications cannot be packaged as containers. The correct choice is option A. The first request after an idle period can experience substantial latency, while a new GPU replica initializes. Scaling to 0 removes active replicas. When traffic returns, the platform must start a new container and the application must reload the GPU model before serving requests, which can expose initialization latency to the caller. Here is how to rule out the alternatives. B. GPU workloads can run on supported Azure container platforms. C. Scale to 0 does not remove startup work. It defers it until activation. D. GPU applications can be containerized. A useful exam pattern is this. Use non-zero baseline capacity when cold start latency is unacceptable for workloads with expensive initialization. Question number 109. Tests careful elimination. Identify the decisive constraint before considering the options. A platform team must install custom Kubernetes operators and custom resource definitions and manage them directly through the Kubernetes API as part of an AI workload. Which hosting platform provides the required Kubernetes control? Eliminate every option that violates even one requirement. Next, option A, Azure Container Apps. Next, option B, Azure Functions Flex Consumption. Next, option C, Azure Kubernetes Service. Next, option D, Azure Container Instances. The best answer is option C, Azure Kubernetes Service. The decisive reason is AKS exposes the Kubernetes API and supports Kubernetes extensibility such as CRDs, operators, custom controllers, and workload manifests that depend on direct cluster-level orchestration control. The incorrect choices are plausible, but unsuitable because A. Container apps abstracts the underlying Kubernetes control plane from the customer. B. Functions Flex Consumption is serverless function hosting, not a Kubernetes cluster. D. Container Instances runs containers without exposing a Kubernetes control plane. Choose AKS when the workload requires direct Kubernetes API access or Kubernetes native extensibility that a managed abstraction does not expose. Focus on the key wording in question number 110. The key exam clue is contained in this scenario. A containerized model service needs more than a minute to initialize its model files before normal health endpoints can succeed. Standard liveness and readiness checks must not cause the workload to be treated as unhealthy during this initial startup period. Which probe type is specifically intended to protect a slow-starting container until initialization succeeds? Focus on which option satisfies the complete requirement. Now examine choice A, startup probe. Now examine choice B, readiness probe with an aggressively short timeout. Now examine choice C, no health probes of any kind. Now examine choice D, liveness probe configured to run continuously during initialization with no startup protection. After elimination, select option A, startup probe. Here is the reasoning that confirms the answer. A startup probe is designed for applications with slow initialization. Until it succeeds, normal liveness and readiness evaluation is held back, preventing premature failure handling during startup. B. A short readiness timeout does not protect a slow starting process from startup failure behavior. C. Removing all probes sacrifices health detection after startup. D. Liveness checks alone do not provide the startup gate requested. Remember this decision rule. Use startup probes for slow initialization, readiness probes for traffic eligibility, and liveness probes for restart-worthy, unhealthy states. Question number 111. Focus. The focus now shifts to flex and Kata scaling. Scenario. A development team is comparing Azure Functions Flex Consumption with Classic Consumption and reviewing Azure Container App scaling behavior. For each statement, select yes if the statement is true. Otherwise, select no. For the first statement, verify. The documented maximum scale-out for Flex Consumption can be substantially higher than Classic Consumption, although regional subscription quotas can impose a lower practical ceiling. For the second statement, verify. A Kata custom scaler in Azure Container Apps is limited to HTTP concurrency and cannot react to external sources such as service bus queue depth. For the third statement, verify. Flex Consumption supports virtual network integration, unlike the Classic Consumption plan. After checking the full claim, statement 1 is yes. Current functions documentation lists a higher Flex Consumption maximum than Classic Consumption and separately applies regional subscription resource quotas. After checking the full claim, statement 2 is no. Kata custom scaling can use service bus and many other external event sources. After checking the full claim, statement 3 is yes. VNet integration is a documented flex consumption capability and is not supported by classic consumption. Exam strategy. Separate plan maximums from subscription quotas. And remember that container apps custom Kata rules are not limited to HTTP traffic. Let's analyze question number 112. Review the scenario and identify what must be achieved. A team compares a blue-green release on AKS with a similar release on Azure Container Apps. In AKS, 2 deployments are exposed through a Kubernetes service. In Container Apps, 2 application revisions are active. What is a key operational difference between the 2 approaches? Now compare the choices one requirement at a time. Option A is on AKS. The team can switch the service selector between deployment labels, while Container Apps can route percentages of ingress traffic to active revisions. Option B is AKS cannot implement blue-green releases. Option C is Container Apps requires an AKS service object for revision traffic. Option D is both platforms use the same service selector mechanism. The option that satisfies the complete requirement is option A. On AKS, the team can switch the service selector between deployment labels, while Container Apps can route percentages of ingress traffic to active revisions. This option satisfies the complete requirement because AKS exposes Kubernetes services and selectors that teams manage directly. Container Apps abstracts those Kubernetes objects and provides revision management with percentage-based ingress traffic splitting. Check why each remaining option is not the best fit. B. AKS can implement blue-green deployment patterns. C. Container Apps revision traffic does not require the customer to manage an AKS service object. D. The 2 platforms expose different operational abstractions. Watch for this clue in similar questions. AKS exposes Kubernetes deployment primitives. Container Apps provides higher-level revision and traffic management features. Question number 113. A premium Azure Container Registry stores a large inference image used by AKS clusters in several Azure regions. New nodes experience avoidable pull latency because every cluster currently retrieves layers from one registry region. Which registry configuration most directly reduces the network distance for image pulls across these regions? Review the options. Choice A. Enable AC or geo-replication in the regions that host the clusters. Choice B. Disable image layer caching. Choice C. Increase only the AKS VM size. Choice D. Move all image pulls to a public registry. The required response is option A. Enable AC or geo-replication in the regions that host the clusters. The requirement to solution match is premium AC or geo-replication synchronizes registry content across selected regions and routes clients to a suitable replica, reducing network distance and image pull latency for multi-region deployments. Now eliminate the distractors. B. Disabling caching increases repeated layer transfer. C. A larger node does not move the registry closer to the cluster. D. Moving to a public registry does not provide controlled regional AC or replicas. Use this elimination rule in the exam. For multi-region container deployments, premium AC or geo-replication provides one registry endpoint with regionally replicated content. For question number 114, separate the requirement from the distractors. Pay attention to qualifiers such as least, most, and minimum. A containerized enrichment process should start only when work appears in an Azure Blob Storage container, process a finite batch, and terminate after the work completes. The event source can be monitored by a supported Kata scaler. Which Azure Container Apps compute resource best matches this run-to-completion pattern? Compare the options by fit, not by familiarity. Consider option A, an event-driven container apps job. Consider option B, a continuously running container app. Consider option C, an AKS deployment fixed at one replica. Consider option D, Azure Container Instances configured with restart policy always. The correct choice is option A, an event-driven container apps job. The key clue points here because container apps jobs are finite duration workloads that start, perform work, and stop. Event-triggered jobs use supported Kata scalers to determine when job executions should be started. The remaining options fail one or more requirements because B, a standard app is intended for continuously running services. C, A fixed deployment remains running instead of representing an event-triggered run-to-completion job. D. Restart policy always conflicts with the requirement to finish and remain stopped. A useful exam pattern is this. Use container apps jobs for finite work. Use container apps for services that should remain continuously available. Approach question number 115 by checking every constraint. This question moves us into container hosting choice. Look for the wording that eliminates the distractors. A cloud team must select an Azure hosting option for 4 different AI supporting workloads. Match each hosting option to the scenario it fits best. Use each destination exactly once. Start with the left side concepts. Candidate 1 on the left is Azure Container Apps. Candidate 2 on the left is Azure Functions Flex Consumption. Candidate 3 on the left is Azure Kubernetes Service. Candidate 4 on the left is Azure Container Instances. Now compare them with these right side definitions. Right side choice A requires custom Kubernetes operators and CRDs with direct orchestration control. Right side choice B needs a simple isolated container run with no orchestration requirements. Right side choice C needs event-driven function execution, virtual network integration, and optional always-ready capacity. Right side choice D needs a long-running microservice with Kata-driven scaling and Dapper building blocks without direct Kubernetes management. Here are the pairings after elimination. After elimination, match Azure Container Apps with needs a long-running microservice with Kata-driven scaling and Dapper building blocks without direct Kubernetes management. After elimination, match Azure Functions Flex Consumption with needs event-driven function execution, virtual network integration, and optional always-ready capacity. After elimination, match Azure Kubernetes Service with requires custom Kubernetes operators and CRDs with direct orchestration control. After elimination, match Azure Container Instances with needs a simple isolated container run with no orchestration requirements. Container Apps provides managed microservices with Kata and Dapper. Flex Consumption provides serverless functions with VNet and always-ready options. AKS provides full Kubernetes control, and ACI fits simple isolated container runs without orchestration. Choose hosting by the control plane you need. Functions for code events. Container Apps for managed microservices. AKS for Kubernetes control. ACI for simple containers. Move to question number 116. An Azure Container Apps environment has Dapper enabled and uses Azure Service Bus Topics as the pub sub-broker. Complete the Azure Container Apps Dapper component configuration by selecting the correct component type. Statement 1. Identify the clue in. Set the Dapper component type property to the blank. Compare 1. State.azure.cosmosdb, pubsub.azure, servicebus.topics, or bindings that HTTP against the requirement. After elimination, Statement 1 uses pubsub.azure, servicebus.topics. This selects the Azure Service Bus Topics implementation of the Dapper pub-sub building block. Remember this decision rule. For Azure Container Apps Dapper components, distinguish the Container Apps component type schema property from the generic open-source Dapper component manifest structure. Next, question number 117. This is marked hard, so do not choose from service recognition alone. A Kata rule must scale a worker according to the number of active messages in an Azure Service Bus queue named inference jobs. Complete the trigger configuration. The first blank appears in. Set the Kata trigger type to the blank. The candidates are 1. Cron, Azure Service Bus, or CPU. The second blank appears in. Set the message count metadata value to the blank. The candidates are 2. True, a numeric target such as 5, or the queue connection string. Complete Statement 1 with Azure Service Bus. Azure Service Bus selects the Service Bus scalar. Complete Statement 2 with a numeric target, such as 5. Message count represents the target number of active messages used by the scalar, not a Boolean or credential value. Exam strategy. Kata scalar metadata contains workload thresholds. Authentication configuration should be kept separate from numeric scaling targets. Let's break down question number 118. Background. AdventureWorks operates a fraud scoring platform with a GPU-backed inference service. Current environment. The model requires a lengthy initialization before it can serve requests. Business requirements. Sudden traffic spikes should be handled with minimal additional startup latency. Technical requirements. Autoscaling is required. but the design should avoid paying the full cold start penalty whenever traffic resumes after idle periods. Which scaling posture best satisfies the requirement? Review the options and eliminate any clear mismatch. Choice A. Configure a non-zero minimum replica count to retain baseline warm capacity while still allowing scale-out. Choice B. Set minimum replicas to 0 and accept initialization on every idle-to-active transition. Choice C. Run exactly one replica and disable auto-scaling. Choice D. Require an operator to change replica count manually. The option that satisfies the complete requirement is Option A. Configure a non-zero minimum replica count to retain baseline warm capacity while still allowing scale-out. The decisive reason is a non-zero minimum keeps at least some initialized capacity available, reducing the chance that a sudden request must wait for the entire GPU model startup path, while still allowing the service to autoscale above the baseline. Here is how to rule out the alternatives. B. Scale to 0 exposes the full initialization delay after idle periods. C. One fixed replica removes scale-out capability. D. Manual scaling cannot respond reliably to sudden spikes. Watch for this clue in similar questions. For expensive startup paths, use warm baseline capacity when latency is more important than eliminating all idle compute. Question number 119. Focus. Background. AdventureWorks also runs a lightweight pre-processing component that receives little or no traffic overnight. Current environment. The component can be implemented either as a container app worker or as an Azure Functions Flex consumption workload. Business requirements. Idle compute cost should be minimized. Technical requirements. The selected implementation should be able to reach 0 active workload instances when no work exists. Which configuration best satisfies the requirement? Options. Option A. Use container apps with min replicas set to 0 or flex consumption functions with no always-ready instances required for the workload. Option B. Run 3 fixed AKS replicas continuously. Option C. Use an always-running GPU node pool. Option D. Run Azure container instances with restart policy always. The best answer is Option A. Use container apps with min replicas set to 0 or flex consumption functions with no always-ready instances required for the workload. Here is the reasoning that confirms the answer. Container apps can scale a workload to 0 when its minimum replica count is 0 and no scaling signal is active. Flex consumption can also scale to 0 when the function workload does not retain always-ready instances. The incorrect choices are plausible, but unsuitable because B. Fixed AKS replicas continue consuming compute. C. An always-running GPU pool does not minimize idle compute. D. Restart policy always is designed to keep the container running rather than remain at 0. Use this elimination rule in the exam. Scale to 0 settings are service-specific. Container apps uses replica bounds, while flex consumption uses dynamic scale with optional always-ready capacity. Work through question number 120. Step by step. Background. AdventureWorks is modernizing several containerized services. Current environment. An on-premises network is connected to an Azure virtual network. Business requirements. A managed container platform should integrate with a virtual network without requiring the team to operate an AKS cluster for the service. Technical requirements. The selected service must provide Azure Container Apps environment networking and private connectivity capabilities. Which platform best satisfies the requirements? Check each option against the exact requirement. Choice A. Azure Container Apps with virtual network integration. Choice B. Azure Container Instances as a standalone container group without a container apps environment. Choice C. Azure Kubernetes Service with customer-managed Kubernetes orchestration. Choice D. A standalone virtual machine running the container directly. After elimination, select Option A. Azure Container Apps with virtual network integration. This option satisfies the complete requirement because a container apps environment can be integrated with a virtual network and supports managed networking and private connectivity patterns without requiring the team to operate an AKS cluster. B. Azure Container Instances can use virtual networking in supported configurations, but a standalone container group does not provide the container apps environment capabilities required by the case. C. AKS supports virtual networking but violates the requirement to avoid operating an AKS cluster. D. A standalone virtual machine does not provide the requested managed container apps environment. A useful exam pattern is this. Choose container apps when you need managed container hosting with container apps environment networking while avoiding direct Kubernetes cluster operations. You have completed set 3 of the AI-200 Microsoft Certified Azure AI Cloud Developer Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.